I'm gonna go back today and do a little bit of Unreal Engine 5 development, which I haven't done in a long time. I think this will be fun. I have some ideas. I kind of want to... The part of what slowed me down from dev on the other one is that I realized that it was quickly getting... The complexity was getting out of hand with what there was on my plate with it because of the way I did the randomization. So I want to do a more generic purpose randomization where instead of randomizing all the parameters for a thing, I just randomize a core nugget, and then when I determine what the thing is, I can feed that nugget into socketable randomizers that will generate the like lower details. And to do that, it's going to take a little bit of a change in the way I do things. In particular, I want to simplify the coordinate system from three coordinates to two, with the intention of excuse me, from 3 to 2, with the intention of making that whole thing easier and also having clear distinction only between galaxies and stars rather than galaxy stellar clusters and stars, which just seemed like too much. So, oh gosh, now I have the fucking hiccups. Let's go ahead and make a blueprint function library. We'll call this randomizer functions. So think the time. Oh gosh, these fucking hiccups. How did this happen? Why, God, why? So we need to do some math. Formerly we were on, let's see, what's... fuck me. Int max. Alright. That's min. That's the max. So our total search space is the min minus the max. These hiccups. 2, 1, 4, 7, 4. 6, 4, 7 minus 2. No. Plus that's our total search space. That means that practically we're going to be limited to this because we can't overflow. $10,000. $10,000. So our coordinate space would be then if they were both maxed, it would be this many. Oh gosh, these hiccups are killing me. Shit. Five digits. Oh, 5 digits total. That's why. Yeah, so 5 digits here. Five digits here without overflowing. So yeah, we can do this. No, that's, there we go. Call this oh shit. So back to the Smith. How was I doing it in the other way? So the trick here, there's 3 coordinates that have to go, or actually 6 coordinates that have to go into making this number, right? You got XYZ in the larger scale, XYZ in the smaller scale. So maybe let's just cool it. Probably have some saved logic. Taking a look. you just have 3 randomizers, one for each axis. And make each one responsible for randomizing things of that axis, maybe? I should probably go look at my other project and remember how I did it, but just open another instance of Unreal and open it up and take a look and remember what I did. I remember multiplying by 1,000 and then 1,000,000 and then 1,000,000,000. I want something similar. I want like a universal coordinate and a stellar coordinate. Alright, let's take a look. Randomizers. C from XYZ. Seed from location. Okay. I see. We were... Okay, I understand. So... I was using N64 to expand it. I mean, that's pretty fucking clever. So here we go. Coordinate to seed. It's gonna take in. Actually, let's go back here. Let's go ahead and make our types. Content. Randomizer function. So we'll go ahead and do a struct. This will be universe coordinate. This guy. Single integer. UX M seed UY UZ L X L Y L Z Proceed. Okay. So this is going to have a simpler coordinate structure than the last thing we attempted. I feel like I kind of bit off. The problem with that one is I had so much there that it was really hard to focus on anything, and I felt kind of overwhelmed. I made it too complicated. But I'm taking out one layer of coordinates, which is like an order of magnitude, basically taking a number off the exponent of the scale. We're only going to worry about stars and galaxies, not stellar clusters. I feel like that was really what was pushing it, because I wasn't sure how to do those differently. This looks good. Universe, this looks good for a coordinate. This takes the universe coordinate and outputs an integer. Okay, there's that. The way they did this is okay, this is our salt. This gets added and modded at the end no matter what. This plus this times 1,000. This times 1,000,000. Beautiful. And thinking these are ends. Do I too long? I think I do. Okay. Alright, we can just do it like this. Oh man, it's fun using Unreal, man. It's been a minute since I did this, but it's very satisfying just connecting all the little wires. Carpal tunnel inducing, sure, but satisfying. Plus 5, 6, 7. Integer. Alright, so basically what we're trying to do is make a deterministic way to turn a coordinate into a non-repeating seed. And that means that after each of these numbers, we're going to add 3 more zeros. Alright, what's in 64 max? 64 max. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We have 18, 19 digits to play with here, so let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Alright, perfect. We're good. We're within the bounds of int 64. Nothing else we do should overflow it. So we multiply these by precedingly larger numbers. So I want my coordinates to be between negative 999 and 999. So I'm going to use 1,000 to make sure that we're always offset by more than the number of digits, significant digits that are used. And then we're going to add everything up along with a randomized salt for the multiverse coordinate to throw everything off by a certain amount, right? And now we have to mod how did I do it? Now we have to modulate this number back down to a 32-bit number. Which was here. Oh, did I make this? I might have made this. Yeah, I did. Okay, that's why. Alright, get rid of this. So this is just a manual construction of a modulus. So we divide the main number by the N32 max, which might actually be wrong. Wouldn't it be... Because this still needs a negative range, right? I'm just thinking. Just thinking out loud here. So yes, I'm satisfied this does modulo. Now I'm just not sure. Like, I think that this should actually be a bigger number. It should be the total search space, and then we subtract. Yeah. So that's a mistake in my initial logic. The total search space was on the calculator. It's the total number of entries right here. 64 value is this much. Divide this. Keep this though. We're gonna need it. So if this were to hit 0, I would subtract the minimum from it. Modulo, subtract, and then subtract again. And that gets you between these ranges. All right. Also, this should be 8, because this is the minimum. Oh, well, I could do negative, and then I could pen and all right, there we go. So perfect. So this is C modulo max search. Modulo okay. This, 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 and out comes the seed. All right, there we go. So we have our coordinate object, we have our randomizer. I guess I don't actually have to do this, huh? Okay. All right, so we got that. Now I've got another thing I want to do, which is the concept that I really wanted to expand on, and that was a new struct this will be okay, and this is gonna have a few variables. Composition, temperature, scale, It should actually be seed at the very top. Composition, temperature, scale, density. And these are going to be coefficients. They're not I mean, you'll see as we go. Okay, we can close this one down. I think we got it working. This. Alright, so we got this, and we have coordinate to seed. We want it's going to take, you guessed it, a universe coordinate. This is going to give us, actually, you guessed it, a randomization core. All right. Make randomization core. Coordinate to seed. Random stream. Alright, so, and the idea here being that we can use this as like a, like we can randomize this the same way every time. We don't have to worry about it if we're looking at something from a star or something from a galaxy or something from a planet or whatever. We don't care. We can randomize one of these, and then we're going to have socketable interfaces that take one of these and can generate all those other things from it. And we can kind of determine how we want to use these factors. Like, for instance, maybe for stars, if they exist or not, could be a factor of the density, because we're not using that for any of the display values of it. So we could take the density, and whenever the star rolls like greater than a 0.95, that would be a 5% chance of containing a star. And we could do the same for planets or whatever. So what we want to do here is random float from streams. I did forget that I will have to have some local variables here. Because this is remembering how the randomization works is if you have to do it in a so like if I took this and I just did this, right? This would randomize once, and you put the same number in all of these. But if I do it in a manner that is on the execution chain, this white line here, and to do that, the best way that I've found is to just have a series of sets. And then at the end, instead of hooking directly to this, you just have gets. There you go. Likewise, is it control? No, not control. It must be alt. Alt, yeah. Back. Don't understand. So we're just gonna do it a different way. So do L set X L set Z L offset. Okay, perfect. And now what we can do is we can just stack all these up nice. And now we can do it like this. Because they're on the execution chain, every time one of these executes will be at a different time phase. And so all these random numbers will be different. Make vector yeah. Remember the hotkeys. That's nice. Kind of the question here is, do we go ahead and modify the offset? I think we do. So this is between 0 and 1. But we actually want it to be centered around the point, not just going in the positive direction. So from each one of these, we will subtract 0.5 to normalize them around 0. And then this will go here, and this will go here. Beautiful. All right. All right, so this should generate us a randomization core. So with the things we've put in place, we already have a searchable coordinate space of randomization nuggets that hold up. All right, I'm gonna go heat up some lunch real quick. Bring it back down.
Yeah, that sounds good. How much is left? Well, I'll come up there.
Is there enough for 2 people left?
All right.
All right. Got some chicken and dumplings. Chicken and dumplings from last night. I cooked it, but that's so goddamn good. That is good. All right. All right, so next, how do we do this next part? So now what I'm thinking about is what I really wanted to get into is the logic for scanning the universe around the player and displaying it back to them. The challenge here being that our search space is way too big to have any kind of like omniscient knowledge of what's in our universe. We can only scan areas, and it takes a long time because you're scanning in three-dimensional space, nested coordinate systems. So what I want to figure out how to do is how to do that better. I want seamless transitions between stars. God damn, that's good. All right. So now, let me think. Negative 499 to positive 499 plus 499. So this is one thing. Yeah. So this has got to be plus. Four, five, six. There's six. Here. Much the same way we did for our offsets in the other calculation, where we subtract the half to center it. We do that here too. All right. Great. Looks good. Now, in the other project, now I'm thinking about scanning. So I'm going to have to look into multi-threading. I want the scanning process to like stream in basically the data rather than trying to calculate it all up front, because in my experience trying to calculate it all up front has been too computationally expensive. So what I would like to do is calculate upfront the visible stars around the player and the visible galaxies around the player. And then I want to stream in, after that's done, on the periphery, the things that the player may be able to see if they move in certain directions. And then as they move around, we can bring things into view and bring things out of view, etc. Alright, so we have a randomization core, we have our universe coordinate, we have our randomizer functions, we have a coordinate to seed and coordinate to randomization core, which makes use of it. Now we need a coordinate scanner. Okay. Coordinate scanner. Scan coordinate space. This will take in a coordinate and a scan integer coordinate scan range. Okay, there we go. So this becomes our origin. Local and all right, back here. So since this is local, we'll only deal with the local. X-min X-max Y-min Y-max Z-min Z-max Alright, so here's how we do this. We go plus let's do like this, plus. This is the structure. And it's actually these two. And these two. And these two. One in. One X. Min max, and then scan range. Scan range. Scan range. Scan range. Okay, so that defines our range that we'll be scanning from. I think, if I remember right, let's see what it was. X was the lowest, going up the chain to Z at the highest. But it doesn't matter from here. All right, and this is how you scan three-dimensional space right here. Loop body goes here, loop body goes here. Alright, and so what we end up with here, you can look at this as one big loop. This is where we return after we're done. And inside each of these, this is X, Y, Z on our local. So we need to make universe coordinate X, Y, Z are always the same. This is X, this is Y, this is Z. Multiverse seed is the same. We're in the same universe. Okay, there we go. Now, this spits out a universe coordinate. What can we do with that? We can randomization core. Alright, so this is the bottom of the loop chain, right? The very inside of the 444 crawling that's being done here. So this can tie into the actual generating of the randomized nodes for a given location. but then I need a way to store it. I mean, I guess I could just go in an array, right? And the real trick is going to be figuring out a way to use this logic to chunk up the data that we're streaming in. All right, so randomization core. What would I use as the key, though? I don't think I need it. This is just going to be an array. All right. No. Get. Add an item. Adds an item to the randomization cores. There we go. And that's the end. And then this randomization core. And it can return this. Okay, and then each randomization core is a struct, so I'll need a probably a new blueprint function library. Randomizer function. Randomizer functions. We have two structs in a blueprint class. We need another oh, whoops. Okay. Function library. All right. This is going to be randomization core. String. should make this outputted in JSON. That's the thought that just occurred to me. Let me take a look at this. Hang on. Okay. Type seed do it with caps since we're using caps. Then we close the quote, comma, space, open quote, close the quote, colon, open the quote, add a pen, add a temperature, add a pen, close the quote, comma, space, open the quote, now, close the quote, colon, space, open the quote. Close the quote, comma, space, open quote, density, close the quote, colon, space, open quote, close quote, comma, space, open quote, offset, close quote, colon, open curly, open quote, X, close quote, colon, space, open quote, add a pen, add another pen, close the quote, comma, space, open quote, y, close quote, colon, open quote, add pen, y, add pen, close quote, comma, open quote, z, close quote, colon, space, open quote, add pen, z, add pen, close quote, close curly, yeah, and then after closing the curly, we close the other curly, and we're done. Okay. So, why isn't this moving around? There, there it goes. So we've got the type, the seed, the composition, the temperature, the scale, the density, offset. And then this value we return as a string. Oh. So now, save this, compile. So how can I... Okay, so I just want to print this at the startup window. I forget where that was. Find out blueprints. Oh, it's over here, okay. Open level blueprint. Can play. Make universe coordinate. All zeros. Perfect. Scan. Local chord space. 5. Just do 2. 3 for now. A 9 cubes, right? 1, 2. No. 9 times 27 cubes. Okay, so we start off, we're going to scan the coordinate space, and then for each randomization for a string. And hang on, this guy. Coordinate might be useful here. To save the coordinate it came from. No, I don't think so. So if I run now, can I get the output? Save all. Alright, let's take a look at what we got here. Oh, can see a problem. They're all randomizing the same. That's fine, that's easy to fix. That's why we do this. Randomize our functions. Guess I do need separate ones of these. No, I didn't mean to do that. Okay, that's useful. Boom. Compile. Scroll it down again. Oops. Stop. Save. Random float from stream returning the same value. What? Okay. Okay. I see what's going on. So that's going to come over here instead of... We do want coordinate seed still. But no, that's right. Unless the random stream is passed by reference, the function will make a new copy of it. This is supposed to reinitialize it because this is taking a coordinate that may not necessarily be the coordinate you're on. So that seems correct to me. Seed. I do want this. We're gonna do... Oh, I see what's going on. Okay, I see. L... It's not an array. Okay, let's try that. There we go. That was it. Shit. No, actually, that's correct, right? Yeah, that's fine. And that actually even looks like well-formed JSON. Mission accomplished. It's not quite done yet. Stop. This. Wait a second. Okay, I see. Reverse coordinate. You know what? It's just easier than regenerating all the variables to do it this way, I think. And then we just X, Y, Z, multiverse, zeros, Alright, bam. There we go. Save that one. One, two, three, 4, 5, 6. This closes that one, right? And then, this one opens another bracket. And inside that we have X. Local Y. Oops. Local Z. go. And then finally, in the quote, in the curly. All right. Okay, so now go back to here. Should be able to see. All right, great. Excellent. Now you can take a look. Let's grab a few of them. See how well they map into JSON. Good enough. I should have done it like this. Oh, that looks like JSON to me. Alright. Well, that's good. Structure string space. I wanted to see. Alright, this is wrong though. Currently. Because, and I know why. Randomizer functions. There we go. All right, save that, compile, go. Great, and then we can adjust these with probability curves, right? Like so for temperature, you could have a curve that this float applies to, and have like only the extreme ends be like extreme. Yeah, this is gonna work. All right, quick break. Okay, I am back. So what we have here is the framework. So let's say we wanted to change this up a bit, and we only wanted to see things that we define as stars. So here in my randomization functions, stop. Okay. Scan local coordinate space. So I'm debating adding another parameter to my randomization core, which would just be a threshold parameter. And I think I will. So randomization core, I'm going to get one more float variable. Float. So I don't want to use density for this. I want to have I don't want to have to force feed anything into anything else. So like seed, threshold, composition, temperature, scale, density, composition and temperature, density, scale, offset, universe coordinate, and threshold. Alright, so you don't have to use the threshold when it's being instructed. Threshold. Oops. But the idea here is we can use this as a selector. There we go. I think we can actually do this now. It was failing to set it into a variable means that whenever it needed the stream, it had to go here, which then had to make the stream. So it's making the stream from scratch over and over, instead of using the existing stream to do the calculations, which is what was causing the issues. Is that over here? Alright, save. Alright, so new function, filter randomization cores by threshold. This will take core array cores float single x threshold. Okay, so then we just do R core array break. Randomization core. Filter cores. When this is complete, we go here. We return these. Alright, save that, compile. Now, scan universe, go back. Space. Alright, we have a tangible Starfield as far as like in our local space. At least conceptual. So if I do this. Okay, I broke the log. Yeah, everything's 0. What just happened? Randomize our functions. Filter randomization cores by threshold. Oh. Derp. There. Save. File. Now it's gonna work. Boop. Yeah, there we go. So, if I do that, this is... These are the ones that fell under the threshold. And I also need to go update the structure string logic, but this is all really important stuff to get right. It's core functionality. Fuck. Alright, we'll just do it like that. It makes it a lot easier to deal with. This becomes comma, no, close parentheses, comma, open parentheses, threshold, close parentheses, colon, space, open parentheses, add pin. Here, add pin, dupe. Alright, so go back. Alright, stop. Now if I go to my blueprint again and go here, what if I do 10 and 01? 1% chance to have a star, but a huge search space. Seems pretty solid. And then all of these can be modified by curves. So like if you want lower probability of big planets, you have like an S curve that you modify the scale by, and you pick out a place on the S curve from your max size to your min size. Okay. I think it should actually be like this. All right, great. Oop. Not too many. All right, so let's get more stars. If I were to do 5% coverage, then it would be over here, over here. This is cool. All right, output log. Quite a few more. Quite a few more. hits. The search range. Four and 58 hits, search range 10, match threshold value 0.5. So if I do threshold value of 50%, all of a sudden 4,619 hits. So that becomes like our stellar density, or density of whatever, since we're abstracting the randomization piece of it. Alright, so next I'm going to need to do a little bit of work externally to start thinking about getting a particle system set up with this data. I'm gonna need to do some GIMP. I need my temperature composition gradient 4 stars. Okay, we're gonna do do 500 by 500 for this. Okay. All right, so gradient tool. This big old fat band of yellow stars. I actually kind of want to flip the Alright, so I'm just gonna hang on. Windows, toolbox, gradient editor. Just gonna do a new one. Gradient. Okay. Okay. I do agree that this should be like a dark red, black, brown color. Great. And then fade it into like a full red. Now what about like dithering? Can I turn dithering on here? How do I? Alright. So left endpoints color. Right endpoints color. Okay. A little of color from here to white. The very high end. Something like that for the first one. Okay. Duplicate layer. Duplicate the gradient. Gradient points color. Yes. Okay. Do this one. Mm-hmm. Alright, so these are our star colors. Now, the next part to do is composition. And the way we'll do that, go ahead and do another gradient layer, new layer. Okay, and this one is going to be foreground to transparent. Alright, there we go. This will be our temperature and composition color map for the stars that we're going to add. Oh, yo, what up, man? Just doing some game dev stuff today. Okay. UV5 content this star export. Okay, so we export that, come over here, and now we have this guy. So now I'm gonna need, all right, so first of all, this in here. All right. So now we need a material, and this will be star T star. Hang on. That says this. Default. Tools add. I can find it like this, so just do all right. What? Bullshit, yeah. Alright, default sprite material. That's what I was looking for. Duplicate this. That's fine. Perfect. Alright, now we got this. And this can go in here. Alright, great. And now I just take this. Radius hardness. This will be composition. Texture sample. I forget exactly how to do this. RBG. Okay, I see. Pre-scene. How do I change? Oh yeah, here it is. Alright, there we go. Now, if I raise the temperature, well, obviously we can't go past 1. Uh-huh. That makes this yikes. Okay. Crashed. Sure. Crashed the desktop when I tried to do that. I don't know why. Yes. Fuck. Okay. Scalar, parameter, temperature. Scalar, parameter. Composition. Min. Max. And it's like this. It's the maximum between it and 0.02 and the minimum between it and 0.999. Constrains it in range. Alright, and then make float 2. Texture sample. Save it, since we crashed last time when we were fucking around with this. Great. All right. So there's our particle texture. Okay. Like that, and then, so we don't want to mess with these. This just, I don't want this to be a parameter. I just want this to be a constant. Great. So we have density, temperature, and composition, which just so happen to align with the values that we're generating in our little randomization nugget. And then so temperature and density. Let me think about this. We want like a baseline. Two minus temperature. Temperature plus density plus baseline multiply this by this and temperature and density plus 0.1 Okay. So now we should have our particle texture in a pretty good shape. Density functions. All right. So we got this. Now, let's think about what we have in hand. We have a texture for our particles that will obey the generated temperature, composition, density coefficients on our randomization nuggets. We have a filtered set based on another randomized threshold value of things that we could consider stars. So with those two things in hand, we can begin on the first phase of the particle generation. So let's go ahead and T-star particle blueprints, struct to string, structs, textures, content. Like our system. New system from template. Back. Create an existing system. This will be the Starfield. Oh, I did this. Hold up. Alright, so we run this again, we can see. So searching a 10 by 10 cube, we hit 4,000, or no, a 20 by 20 cube. We hit 4,000 stars with the threshold value at 50%, which is obviously too much. I want to try cranking a couple things. So first I need to go to my blueprints. Open the level blueprint, come over here. Let's try a larger scan range. Let's see if it can do 30 or if it chokes. Probably choke on 30. But we're gonna give it a shot, and instead of doing 5% or 50%, we'll do 5%. And save that size. Let's see how long it takes. Okay, yeah. Infinite loop detected. What's 30 cubed? No. What's 60? Times 60 times 60, 216,000. UE5 disable. full runaway loop or loop in different thread. I'm watching a video to figure this out real quick. Oops. Reset it. We have an infinite while loop, so no matter what. So we have reset runaway. Can we do 10,000 loops? We can. 10 million, that is to say. Output. Alright, 11,000 hits at 5%. That sounds like a pretty good Starfield. Probably could even go a little bit smaller, so let's try 20. Because that actually wasn't too long. It didn't take... Boom. Alright, so we get 3,000 something hits. Search range of 20, threshold value of 5%. And we have all the values we're going to need. So basically these get multiplied by some set distance from the user, and these get multiplied by that set difference as an offset. And then any other cascading things that we need to calculate, we use the seed of that element to calculate. Okay. So we should be able to provide to this a set of objects. I need to figure out how I did that in the other project. Juggling windows and shit. Or actually, I don't even think I put it in this project yet. It's in the first project. Shit. Alright, well that's 3 minutes wasted while I wait on other shit to load. Yeah. Unreal. Okay, so I'm going to grab the first project, Planetoids, and we're going to look at the system from that. So I have to figure out how to get this set of structs into the Niagara system. Along with my local coordinate. So that was Planetoids. the first iteration of this project. This is iteration number 3 that we're starting on today. Alright. It's loading up. Also, I read that they might have enabled Nanite with world height offset. I really hope that's the case. That would help me immensely with this project. Damn, it is taking a million years to load. Has to compile a bunch of shaders. Okay, so I'm gonna go take a quick break, quick bio, and come back when this is all loaded up, and then I can go check my example of how to feed data into a Niagara system and start setting up a Starfield. Okay. Alright. I'm back. Still compiling shaders. 5,000 to go. What up, dude? So, we started re-arc number 3. But we've already made a ton of progress. Randomization and coordinate system is done. Oh. Yep, that's unfortunate. It's not too bad for me, but if I sleep in more than like 10 a.m., I start getting punched in the face by a dog. So, let's see. So we built this universe coordinate. So I'm paring it down from 3 nested sets of coordinates to 2. I think that's going to be more manageable. I'm only going to make a distinction between galaxies and stars. I'm not going to do the whole stellar cluster thing. It's just too much. It makes it feel more insurmountable. So we did this. XYZ, XYZ, multiverse seed. Normal shit. We created the logic. We created a bunch of these functions. Coordinate to seed. Coordinate to randomization core. Scan local, scan universe. Filter randomization cores by threshold. The randomization core is what I was talking about a while ago as one of the ideas that I had that I think will be better. And it looks like this. It stores the seed that was used to generate it, composition as a float, temperature as a float, density as a float, scale as a float, offset as a vector, the universe coordinate that it's from, and threshold as a float. All of this stuff gets randomized. But it's not specific to like planet or star or whatever. No, this is like the central nugget that everything else will randomize from regardless of what it is. Because we have the seed for like when we start going into planets, we'll be using the seed to generate more of these cores for each planet. So we got that. We added a material that responds to some of the values in those objects. So we have density here as a function. We have temperature as a function, right? And we have composition as a function. Pretty normal stuff with regards to all the kind of like breakthroughs and understanding I had on the other project. This is our star color temperature composition map. Just made this quickly in GIMP. And basically what we do is we load that sample, that texture as a texture here, and we feed the temperature and composition into it as the XY for the UVs, and that gives us the color of our star in our particle system. This don't think I need it. So this changes. All right. So this is great because it's going to be much more abstracted, and I think it's going to be a lot more manageable. Like I'm already with it set up this way, I'm already at the stage where I'm about to start constructing the particle system because stop this. If I run this, I can see I'm already generating all the data I need. I'm also, when I do my structs, I'm going to create basically struct to string functions that will output them as JSON. So I have one for this. So you can see like all the information about it. We got the local XYZ that this was scanned at, the multiverse seed of the universe. We have the local offsets that will be used in the rendering process of the the positioning process of the particle system. We have the three values, or we have these two values, or these three values that we were looking at that'll get fed into the material, and then another value that'll be used on the scale of the particle itself. So the next step from here, since I have all this in hand, is to remember how I managed to feed structured information into the Niagara particle system in the first project. So I'm opening it, but it has to compile like 7,000 textures. So I'm in the process of loading it. It has 4,500 textures left to go. So at some point I'm also going to redo like my entire noise library, but I'm going to I might hunt down and see if I can find like a free or somewhat inexpensive program that's devoted to generating high quality random noise. I mean, I was using GIMP and it works. It just takes so long. It's such a grinding experience to do it through GIMP. So now, I guess while that's loading, I'll go ahead and do some research. Pass an array of structs into Niagara particle system. Niagara arrays, set vector array, spawn particles custom positions. And I also need to figure out I don't want to pass an array of vectors though. I want to pass an array of structs. Array of structs as model. I think it might have something to do with Niagara data interface. I'm gonna have to set it up right this time. Data interface. Combine individual emitters into one system which displays the entire visual effect you want to create. There are modules specific to systems, and some elements of the editor act differently when you're editing a system instead of an emitter. When you're editing a system in the Niagara editor, you can change or override any modules in any emitter included in the system. You can also manage timing for included emitters. Modules accumulate a temporary namespace, and then you can stack more modules together as long as they contribute the same attribute. The modules stack and accumulate properly. When writing a module, there are many functions for you to use. Boolean expressions, blah blah blah. HLSL. Paradigms inheritance. Cannot effectively locate and use the assets you already have in your library, which leads to people recreating those assets. Duplication of effort lowers efficiency and increases cost. Hierarchical inheritance increases discoverability. It can be overridden from child emitter. Modules can be added. Dynamic inputs are built the same way modules are built. Dynamic inputs give user infinite extensibility for inheritance. Acting on a parameter map, act on a value type. Any value can be driven by graph logic and user-facing values. Data interfaces. Extensible system to allow access to arbitrary data. Mesh data, audio, DDC information, code objects, and text containers. Data interfaces can be written as plugins. Okay, I still don't completely understand. Let's just take a look in Niagara. So, where did my mouse go? Okay. Read-only value which can be initialized per system and modified externally in the level. Float array could conceivably do it, or vector array. I'm thinking.
Our blueprint. Target. Okay. Action. Box, we're gonna do 10 by 10, and if we and
this isn't working. Let's see. How about make dynamic data. At some point, the other project will start up, and I'll be able to go look at how I did it over there. I don't want to have to chop up a float array manually for thousands of entries. I mean, we could do it. We know how many entries are in it. It just seems lame. I really want to see how I did it 2,800. The player controller not call the game instance. It should be able to. You should be able to call the game instance from anywhere, I think. Interesting. Unfortunately, my calls to that are in the other project. I do remember having to, like, I know you had to cast. You have to get it from somewhere. I don't remember. Fuck, I don't remember. But I'm gonna play a quick game of Magic while this other project loads. I could drag it over because I'm full screen sharing instead of. I don't know where I'll be at. I was at like rank 400 or something last time I was playing. The Neoform deck is well tuned. I have to, yeah. I'm gonna have to, like, once I figure out, I really am gonna have to deep dive into the Niagara system, and it's gonna take me a while to learn it. But once I figure it out, I think that I can do what I want to do. Like, I already have a pretty good grasp on the math, I think. You're basically maintaining an offset of the player in local space, and you're adjusting the position of all the particles based on that offset as it changes. Let's do graphics. I would like to do non-full screen and smaller, please. Okay. While I'm waiting on the rest of these to compile, I'm going to do this. $600 in. I only felt 200. I haven't played in 2 days and only felt 200 ranks. It's pretty good. Yeah, we'll keep this. Opponent is on the play. Ugh, here comes the fucking Thoughtseize. Oops. Alright, make your fucking pick, dude. Of course the first deck I play today is going to be a Thoughtseize deck. And, like, as soon as they hit you with this, you know it's going to be a bad time because they have... They're going to have... If they're playing these, they have 4 Thoughtseizes, you know? So they actually have 8 1-mana discard spells, is what it's going to be. Tarmy. Yeah. Oops. Do this. Do this. 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 No attacks. Alright, friendo. Sure. No blocks. I don't think let's see. So let's think about this. If I take the Wish Call this turn, and he Thoughtseizes me Actually, thinking about it. Alright. Because I could always borrow back the Wish Call Talisman. But I don't want to have to spend the mana. Alright. Let's do it. If he does that and cracks it and then discards us, then we can just win next turn by fetching again. Yeah, see, like, it's not a good deal for him. I mean, he could still have Fatal Push, don't get me wrong. Still gonna try. We have two options. Oh, we win. Alright, how many... Hey, we cleared about 600 textures while I was doing that. That's a bad hand. It's a little better. Photo taking. I'm not sure, I haven't seen that one. Yeah, you can kill it, that's fine. I don't care if you kill that, by the way. Sure. That just means that that food's gonna be useful. And your robber's not. Just burning my goose, man. I don't think it's a good idea. Alright, sure. No box. No attacks. Alright, we win. Sure. Tell me more where that came from, buddy. How's this loading? 746. One more game. Probably win one more game and we'll have it. No green. No green. Okay. I think I'm gonna pitch this and keep on the Kefnet plan here. As like a stall tactic. Turn 3 Kefnet's pretty good. Put it on goblins. Oops. We have the mana we need. No attacks. We want to keep the goose on the board if possible because Kefnet can combo with it. Yeah. Alright, here comes Muxus probably. I would love Stormcaller. It's not a Stormcaller. No attacks. That turns Neoforms off the top into lethal. You can't swing either. That's great. That's hilarious. Decline. That's unfortunate though. I'm gonna go ahead and cycle this actually. No attacks. Alright. He can Muxus with Warchief now, if he's got it. Don't think he does though, or else he would have played something other than that. Franco's not great though. That is admittedly a problem. He can just dive bomb with all those 1/1s now. And now we're just dead. $60 shaders left. Now we're like, ooh, Ultra dead. Oh wait, no, that was Charger. Muxus. Should have played Muxus before you played Krenko, right? I do kind of want to see where this is going. I want to see how big this gets. Alright. The whole project is spinning up. I think it's pretty safe to concede here. Just gonna concede that and close this because I'm almost done loading the other project and I can go figure out how I did it there. All right, here we go. I see. It's like I separated them out into separate arrays, positions, colors, sizes, but I wouldn't have to do that. Not exactly. We would do, and then we go here. Vector array, color array, float array. All right. Okay, we can do this. So I see exactly what we need to do. That's funny. Yeah, that is quite funny. All right. So that means, and then if I bet if I go to the particle system, it's going to have user parameters for all that shit. Yep, there they are. Okay, I see how it works. That's all I really wanted to know. So we're going to have picture array. This would be start positions. Yeah, okay. So sure. Float distance scalar. Star positions. Star float arrays. Lots of float arrays. This would be star densities. Float array. Star. Another float array. So maybe I do the conversion externally to this system. This is a vector array. Should be. These are all float arrays. Okay, stop doing that. Okay, so, and then now can I feed these? Just wondering, thinking out loud. Can I feed these in real time? User offset. Just a vector. User. No, player offset. Player offset. So the player offset will be their offset relative to the origin in the coordinate system. So like, okay, I can close this down. I understand what's going on now. Yep, there you go. That'll do it. Okay, so I think the way this works is we iterate through all the arrays here. I will do I was feeding a count into it, but like that doesn't work if I wanted to update in real time. I shouldn't have closed that other project. I still need to look at the actual emitter. Okay, so I gotta make an emitter here. I need to go look and see. I think it was grid location. but I'll make sure. Yeah, it's grid location. Okay. That's what I thought. Emitter, grid location. Yep. Okay. I see. Okay. Yep. I see. But where is it defining? I'm just gonna work through the one that I have over here. I keep closing it down like, oh, I get it now, and then, oh shit, I'm gonna do this. Sprite renderer. Okay, this empty start particle. Alright, let's take a look. Here it is. Grid location. Grid location. Emitter properties. Local space. Non-deterministic. CPU sim. Interpolated spawning requires persistent IDs. Scalability, good to go. Insert options, good to go. Emitter summary, good to go. Emitter spawn, nothing. Man, go away. Also nothing. Emitter update. All lifecycle system scalability system spawn spawn versus enters spawn count All right. There it is. And then star count. Yep. Spawn time 0. Yep. Particle spawn. So go back up to here. Particle spawn. Initialize particle. All point attributes direct set. Lifetime 0. Color mode. Unset. I'm changing that a little bit. Provide material attributes per particle nada.
Hello and welcome to the Game Dev. We'll hit save. Let's take a look at our material instance. We'll save that. Then we're going to come back to the emitter. We want to attach our new material instance to this mesh. So in our mesh renderer, you can either go to the mesh and put your material instance on the mesh, or you can click on override material, and this is where we're going to place our material instance.
Alright, hold on. So let's just go back, get the rest of this sorted. Initialize particle here. Okay, color mode's unset. Lifetime mode is direct set 0. Color downsize. Position mode is direct set. Oops. Multiply vector. Float. Distance scalar. Select vector. offset. Star positions. Vector array. Select vector from array. Select vector array, direct set. Turn particle ID attributes. This is so much more confusing than most of the rest of Unreal's interface. Particle ID, unique ID. Direct set, particle ID, particles dot ID. Return particle ID attributes. Particle ID. Particle ID index. Particles ID. Boom, got it. Clamp. Star positions. Boom, got it. Okay, great. Vector distance scalar. Great. Mass mode. What's this do? Sprite size mode, non-uniform. Make vector 2D. Select float from array. Direct set. And particle ID attributes. ID index. The array is sizes. All right. All right, great. Looks good. Particle state. Infinite particles. Sprite renderer. Remove this. Okay. Now, I got changing material parameters. I guess I should. Okay. Learn a thing. I need to. No, I don't think that's right. Okay, so we got size in, positions in. Now we need temperature, density, and composition fed into the material. That's what I'm trying to figure out how to do. Per particle. That's going to be here, right? Provide custom parameters. Provide custom parameters to Niagara particle texture.
So if I change it to something higher than that, let's say 50, you're going to notice that these sprites start rotating around, and
Hey, this is what I need. Okay, great. User parameter.
maybe, so you can read it that way. And you can update sprite.
Particle
sprite rotation
update.
rate. I'm going to delete that one. This module allows me to give these particles a rotation rate, so they constantly rotate or spin around their own pivot point. So if I change it to something higher than that, let's say 50, you're going to notice that these sprites start rotating around, and already have here. I'm going to create a new one from scratch. So rotate sprite or sprite rotation rate. I'm going to delete that one. This module allows me to give these particles a rotation rate.
No, I don't.
One thing that we are missing here is
I want to change the texture.
user parameters, using custom parameters inside of Niagara emitters. I'm using one of the old setups that we have created using leaf textures. As you can see here, this is where we
Custom material parameters per particle Niagara.
particle, and my sprite rotation mode is set to random.
Yeah. You probably do need a camera manager. Let's see. So what the fuck? I would expect it to be here. Source mode. Okay, for one thing, that's the material. Later spawn. You haven't done any of the like human, well, maybe just a tiny bit of the human modeling stuff. I don't wanna, shit. How can I figure out how to do this? So I need to be able to feed per particle, change material attributes per particle, night.
Hello and welcome to the Game Dev Outpost. In this video, we're going to be... So if you're doing effects, it's really important that in scale color, we have scale RGB and scale alpha. And in both of these, we can change the color, or we can change the alpha. But that is only possible because of the material. So if we go to the sprite renderer, you can see that there's a default sprite material on here. What I'd like to do now is walk you through how to set up a material for particles. So we're going to move this out of the way, and we're going to go to our content browser, and we'll hit save. Now, the use default is what made it. So you can see that they're rectangular. Take that. Now, a few different ways to put this to 10.
You don't want it to work like that though.
Now, if you come to the material instance, alright guys, this
Okay.
covers making an
Useless. Change per particle material attribute. Ha 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 ha. I'm assuming I probably have to do no idea what these do. I'm actually not gonna do that yet. These three. This is useless. So how the fuck? Well, so at the very least, okay. I think we've gone past the point where this stuff needs to move into its own blueprint, so we're gonna do okay. Alright, so at the same time as we're doing this, All right. So what arrays did we need? I think I just want to make a little helper function to do the conversion between a set of these to the set of arrays. So that's going to be scan, filter by threshold. Miser factor. Adapters. Niagara adapter. No, I don't want that, actually. Alright, just right here, we'll just do... core array. Okay, 1, 2, 3, 4, 5 positions. So 4 of these and 1 vector array. And an integer count. Shit. Come on. Click properly. Alright. So now we start talking about how we calculate the actual position. We have a local offset here. We have a greater XYZ offset here if we so give the difference in location in local space to the player. That would represent a 1 or a full block of space. And then that becomes a vector which then has the player offset and the local offsets applied to it. So we would then do plus and so this basically converts us back into floats and sets us up with our first offset calculation, which is the offset from the local offset of the star itself. The second offset is going to be the player. And to calculate that, we will subtract and break player's offset. And then that becomes the actual location data we feed to the vector. Okay. Boom. 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 And that's it for the loop body. Then completed will return everything. All right. I think that's right. So we know this stuff's working. I'm going to go ahead and actually, it should have been here. Okay. We'll just leave this at 0 for now, and leave this at 0 for now. Now, yep, we don't have to do this anymore. Tap the Niagara arrays. Alright, great. Star count. Alright, so now we can go to our space level. We can get rid of pretty much all this now. And we're just going to spawn one of our blueprints in the level. Um, So then I could come in here and I can just here change all these default values. All right. Come on now. All right, done. Okay, I need to spawn something just to know that as a sanity check. So let's go ahead and just... Sure. Oh yeah, distance scalar has to be set too. Okay, I think I can close the other one now. The that float. Distance scalar. Okay, sanity check is successful. That's great. So where's this? 300. Reset this. Starfield. Okay. Let me go look at the other things that I did to set up the Starfield and make it render, because I should be feeding it at least locations at this point. Like, the colors aren't going to work because I haven't figured out how to dynamically provide that information to the material on a per particle basis. And I may not be able to. I may have to figure something else out, but I will. Planetoids. Back open. It's also a little chilly down here. I think I'm gonna go grab my fuzzy robe while this loads up. Well, shit, my fuzzy robe was already down here. It was just on the couch. Okay. Oh, yeah, that's better. Alright, calculates it. Nebulous sphere, Starbucks. I want to see your blueprint, please. And at some point, I'm going to get some Raymarch nebulas. I will bash face on that as long as it takes. I just gotta... Okay, planet initializer, solar system... Let me see. Here we go. Make transform. Star detail scanner. Logo source. Spawn actor Starfield generator 2. Okay. Starfield generator 2. Here it is. Okay. Spawns the nebulous. Okay. Initializes the Starfield. Here we go. Set, 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 set. That's all it does. Starfield. just sets those. Spawns a nebula sphere. Caps it. Okay. Alright. From everything I can tell, it's Starfield. 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 I'm going to be using a lot of that code later, but I'm going to look at the system spawn info. On Starfield. Nothing, nothing, nothing. Okay. I mean, according to what I can see, this should work. Let's try increasing the distance scaler by a lot. Starfield. All right. Okay. No dice. That is it. That is all they do. Save. I think that maybe... Okay. Downsize this. I think that maybe I have to have... default sprite material. Copy. Close this. paste. Save. No, not quite. I will do a shape sphere. That way I can at least have some visual context. So here's this. Oh wait, hang on. Blueprints, Starfield. Alright, so I think the only thing to do now is to like pull this off and make sure that all the spellings and shit matches up. Okay, so first of all, we'll do them in order. That they come in on. Okay, there's that. Next, player offset. I don't need that anymore. Delete. Okay. So I changed this up a bit. I'm removing. I already removed it. The user distance scalar stays, composition stays, count stays, density stays, position stay, but the user offset is gone because we calculated externally. And then Will that just work? I doubt it. Then we go back to our Starfield. Initialize particle. Scale. Direct set. This would be just one for now. I can come up with that later. Sprite size, non-uniform, direct set, ID index, stretching. Oh yeah, they would be way too small, right? Okay, both these are the same. That's pretty funny. Okay, so I think this is way too small. Let me check how I did that over here. Here it is, and then here we're looking at the scale. Let's just try this. So what happens if I multiply the size by 1,000? Still nothing. Well, shit. I'm gonna look at the other one over here for a bit. Starfield. Oh. Nah, not yet. Not good enough yet. Interstate system. Interstate system. System. Yes. Emitter spawn. Properties. Local space. Yes. What's this do? Okay. I mean, that is the same. Spawn burst instantaneous. What's this look like over here? Okay. Seems fine. Particle spawn. Init particle. All. Point attributes. Direct set. Lifetime 0. Color mode. Direct set. Position mode. Direct set. Position offset. Multiply vector. Vector from array. Direct set. Particle ID attributes. ID index. ID. Clamp. Star positions. B. Vector from float. Distance scalar. Position offset coordinate space. Local. Try local and then try world. World is what? The other one's using. World. It won't be able to be world. It will need to be local, but just want to see if I can get them rendering. Dang it. Okay, so I'm gonna also try this. Starfield renderer. Right. Save. No, don't do that. Here, do this instead. Oh no, I can't find it. Minecraft. Trying to figure out what the heck I'm doing differently. Didn't begin play. That's where I'm calling mine. Can I debug? I can debug. Maybe Starfield. Still nothing. Oh shit. This is all fucked up. No fucking wonder. No wonder. It's all fucked up. Come on. Ah ha 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 ha. Okay. Okay. we got something. We can now go back to here and remove this, I think. Save it, compile it. Okay. At least it's doing a thing. You'd think, being a game company, they would fix the fact that you can flip your camera axis by accident. Okay, so I think it's putting all of the points on the same point. No. How about that? How about that, motherfucker? Okay, I want to see what's going in to the algorithm. So, boop. Up a log. These are valid coordinates. And then those will get multiplied. What's the, do I get any non-data interface? What's this say? Wow, Google has nothing. Alright, so what if, bear with me, just to be sure, if instead of doing the multiplier inside here, I could go to here, adapt to Niagara arrays. Times and then go here, or no. Here, change vector from float, value 1, save. Nope. Let me take a look then at this project. Starfield. Nope. This one over here, Starfield. Okay, let me look at these. Vector array. Float. Set vector array. Oh. Oh my god. See, this is what makes me lose it. Okay, this is it right here. Star positions. Save it, compile it, space. now, well, they're probably way too far away because I made. Okay, this is everywhere it's supposed to be. Oh, shit. Oh, we'll figure it out in a minute. Why then? Okay, so Starfield, initialized particle being multiplied by 1. Star positions, star positions. Star positions. Set this, save. Okay, we'll go back to this now that I know I think it's working. I don't know it's working. I think it's working. Starfield, direct set, distance scalar. Here. Save. Calculations. Alright, get rid of this. Save. Pilot. Alright. Star compositions. Built like that. Star. Count. Star densities. Star positions. Star sizes. Make vector 2D. Okay, that's where we wanted to go. Randomization. Okay. Okay. Now we're getting somewhere. The offsets are incorrect somehow. Or are they? I mean, maybe it is random. Go to 1. No. They're not random. Alright, that's pretty cool. Let's see. Alright, now I can go back to my Starfield function. Let's go down to 100. Save that, compile it. Go back to the Starfield itself. Change the renderer back to our texture that we wanted to use. Try that. No. Can I not move? And then as soon as we figure out how to feed those values into the the material itself from within the Niagara system, that's when it'll start looking good. So store sizes. so, and then save it back into the particle system itself. Come down here to the scale part. Initialize particle, position offset like this. This is wrong. It'd be just direct set it to 1 for now. I do want to do that. Copy. Vector 2, make vector 2D. T. Save it. Then we go back to our generators. Now we don't have to worry about doing that. This nonsense here. All right. Save all. Okay. Well, they're all the same. All right, and then so this gets a difference of the x, y, and z of the mass of the like large scale coordinate. You're assuming they're in the same universe location. Then am I calculating this right? I feel like that's correct. Make vector x, y, z. Offset randomization core. Randomizer functions. Um, Feels like that should all be correct. But I'm definitely seeing like... Alright, it'd be easier if I go ahead and go here, change this to 10 and this to 2. Something is wrong with the randomization. It's falling into patterns, as you can see, and rendering a ton of them right here for some reason. I could also do randomizer functions. Float range. Feels a little better. Not from the outside looking in. A little bit more uniformly random. The scale seems pretty uniform, but it's supposed to vary by quite a bit. I'm not sure what that's about. Let's try Okay. Okay. They're different sizes. Like this one's very small. I suspect whatever's going on with the randomization that's causing it to not be fully random. A bigger field. Just in case. Why do that? It's like not all of them. numbers don't look bad to me in these values. Tap to Niagara arrays. Could also be a product of the threshold generation, possibly. So the random stream. Very confusing. 15. Zero, 3, 6, 9, 12, 15. Distance, scalar size, temperature sizes, densities, positions. Something is wrong with this, and I don't know why. Which direction am I moving right now? better, but it still has some very obvious patterning, which means that something's wrong in the math somewhere. Let me go look at some stuff on the other project. That's definitely correct. I'm not 100% sure. Let's go look at here. Initialize location. Position of offset. Multiply vector. So we grab the corresponding vector from star positions and multiply it by the distance. Per particle, sprite, material, parameter.
Hold on a second. Tricky. For instance, this right here looks like some kind of timing issue. And then the other thing that's frustrating is having to constantly redrop the blueprint whenever you make a change to it, or else it doesn't change, and you're like, why isn't this working? And now I don't know if it was not working or not. Although that looks a lot better. But now I don't know what I did that fixed it. uh, $50,000. 1,000. And then I wanna say okay. Particle. Attributes. Index. Where did I calculate the offsets in planetoids? Absolute, set relevant, check bounds, get element stream, the absolute, relative element location, See, like, this over here is a problem. I fixed this on the other project. I don't remember how. Very frustrating. I'm gonna go look at the other project, not Planetoids, the newer one. Wait, cancel. Calculate Starfield details. Starfield Generator 2. This Where's my fucking blueprint? Window, view. UE5 reshow blueprint. Reshow event graph. Drop down left above variables. And it's like, it's so good most of the time. There it is. Okay, I found it. Okay. Okay, here it is. Local offset. Wait, what? Stream. Get a random integer. Subtract. So I either get 0 or 1, then I subtract 0.5 from it, then multiply it by 2, so either -1 or 1, and then a random float in range from stream times that. Okay, I can try that. I did it this way. I don't understand why I did it like this. So let me think about what this would do. I get a 0 or a 1. Minus 0.5 gives me either positive 0.5 or negative 0.5. Times 2, -1 or +1. So I'm randomizing if it's going to go in either direction. And then I'm multiplying by the amount. So, all right. And then it from stream. An integer in range from string. Minus 0.5. Positive or negative?
this works, I'm going to be kind of dumbfounded. It's better. so that's clearly wrong. So we go back to here. No, not here. Here. Jesus Christ. Nope, this from the other one. So confusing. Okay, here. And then instead of this, we'll do random float and stream. And manager from stream. Okay, I see why I did what I did. Now. This gives us positive or negative. Feels more like it. No longer seeing patterns. Why does it have to be like that? It's so weird. There's still some little patterns. Come later. Literal float, literal int. Okay, there we go. Size is back. Looks good. Sort of. So gotta figure this out. Could I also just do... Damn, I can't believe I'm having such a problem with this. Structure strings, randomizer functions. Can I also just do random float minus 0.5, right? And then have that go here. And what if I do like that? Alright, fuck it. We'll just go with this because it looks good. Oh, it's not gonna work till I delete this and make a new one. Alright, now we need to get it back into local space. Starfield. Position. Local. Save. Go. Still work right. Seems that way. Let's make it bigger. Okay, now, thinking. So now I want to attach this to the player camera. BP Starfield. Okay, I can't move anymore because I've bound the location to my player location. So now it's time for the logic that I was thinking about, right? So so I bound the Starfield to the camera location with this code. What I want to do is calculate offset. So let's say every time you travel 100, you will move 1,000 or something like that. We'll do 100, 100, 100. Yep. And then this would become the player offset. I want player offset as an input to the Niagara array, I think. Because I want to be able to update just that on the event loop.
So that is Starfield, particle location, position mode, offset, multiply vector, select vector from array. Times the distance scalar, but we want to modify this a bit. Player offset. So we subtract the player offset from the vector, and then we multiply that by the distance scale. Say that. So what does this mean? It means that we should swim. Well, we'll see. We'll see. Save, and then here we're gonna wanna okay. Does feel like it's moving. Alright, so the distance scalar I have here is 10,000. I want to do 100. Wait, no, 10,000. Yep, okay. And Is it moving? I can't fucking tell. It's definitely not moving at the rate that it should be moving. No. God damn it. Player offset. Okay. I don't think I can do that much math over and over and over and over and over and over on the event cycle, but we can try it. Yeah. It's not feasible. I'll probably lock up my computer here. So here's what I'm realizing. Rather than this being a Hey, buddy. What you doing? Hey, Ted. Hey. Hey, friendo. Hey, buddy. You want to get in my lap? Hey. Come here. Come on. Yeah, come on up. Come on, you can do it. Come on. I'll give you pets. Come on. Come on out. Hey. Hey, friendo. Oh, gotcha. I gotcha. All right. Ooh. Yeah, that's it. Hey, hey, you turd. You silly turd. Alright, we cracked it. I mean, it's not... We haven't figured out all the math yet, but this is definitely the methodology behind it. Also, I've got it flipped, because backwards is going forwards and forwards is going backwards. Down is up is down. So that means... Multiplication... If I negative these, maybe? Seems reasonably likely. Forwards goes forwards, backwards goes backwards. We're not actually moving very far. But we're moving the Starfield in conjunction with our movement to make it feel like we're going a lot faster than we actually are. This is nice because it gives us the ability to do things like fade everything out. Like if I wanted this to be slower, I can go to 1,000. And now 1,000 of my units will equal 1 of these units. And I can make this real big. So let's say this was 100,000, right? Now every time I go 1,000 units in game, I would have gone 100,000 units. In the actual Starfield. This is going to give us the ability to do interstellar travel, along with some LOD stuff. Now I have to figure out how to dynamically update the material parameters for each particle based on user inputted data. I know how to change the color, but that's not what I want. I want to provide some inputs to my materials. Is this working? So this proves that it's possible, that what I want to do here is possible.
Maybe let's talk about it when I come back with Teddy.
Okay, and now, so let's say we wanted to make this $10 million. $1 million is probably too much, actually. Let's do 100,000 here. Size 1,000. And we want to make it so that every time we travel. So here's the real fun part of this, which is using it to not speed up the transit but slow it down. So I actually need to make this smaller. So like if this is 1,000 and this is 10, right? And what if I want to slow it down? I want it to go slower than I actually go. So if I do these at 10,000, then for me to move 1,000 in the star map, I should have had to move 10,000 in the game. And that would be approximately the distance between a star. Alright, so we see that. Now what if I did 100,000? And this is more like what it would be, because like we want it so that eventually to travel the distance between one star, this would be like 80 million, right? But we're going to give the user the capability to go that fast. And then the Starfield can just float around them as like a, with like a post-process render. This is still going to, oh, I'm a fool. I am a fool. This is very annoying, by the way. Alright, good enough. That doesn't feel right. Float. $100 is what we're gonna do. It's gonna be teeny tiny. Get rid of this messy integer crap here. Okay. Let's delete this, play this, clear this. I say play it like fucking Magic the Gathering. I played my Starfield card.
Okay, hang on, that's wrong. No, it's not exactly right. So it should be slowing it down way more. So let me go back and look at this. I think I get it. It's actually this is the modifier to this. Now it's like way too high. Let's turn it down so that we can make a comparison here. Every time we go 10,000, it should move 1,000. I mean, there's definitely like some wonkiness here. I'm not particularly worried about that. I just want to know the math's right. So I've definitely gone okay. So player on So the concept is valid, but it needs to be executed a little differently. The Starfield needs to be a part of like the player object basically, and travel around in the same local frame of reference as the player object. And then instead of constantly setting it to be origined at the player, throttle UE5 throttle event tick. So like let's see. So we can also make this a lot less obvious if I do something like, so if we make it 10,000, right? So it's reasonably far away, and then I set this to 100. We will fly around. We should fly around real fast. But if I set it to 100,000, we should fly around real slow. Let's see. Definitely blew it somewhere. I'm not entirely sure what the completed math for this ends up looking like. I'm gonna have to face bash on it for a long time probably. So let's slow it down intentionally. Oh, it's not gonna work. Wow, you can just do that? It's kind of crazy. And yeah, this slows it down. So then if you wanted to, you could do, now you can do things like, this could be 1,000, 1, 2, 3, 100,000, populating, well, you can, if I've got a 30 by 30, then that would be 60 times 100,000 is 6 million. We can go up to 80 million. So we could go up in order of magnitude. We can go a million here, right? And then we can make it so that it only travels a million after, well, we can make it, we'll do 10,000. So now, oh, whoops. So now we should move much faster than we're actually moving through the Starfield. Even though it takes a long time because the Starfield is huge now. And what's more fun is if I came down here and I wanted it to be even faster. We could take it down to 100. A hundo file. And now, oops, delete, place, reset, double click, go. And now we're moving millions of kilometers, even though we're still going the same speed. And this is exactly what I needed, the ability to throttle these up and down based on the scenario. And now we can come back out here, now that we have a big number here, a million. So we have right now a search space of 30. That means that we're a cube with a sort of like pseudo radius. This is actually 60. So we got 60 times 1 and 60 million, that's entirely within range. We can change the size. Oh, whoops. God, I hate that. I hate it. I hate it. I hate it. 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 Update the blueprints that are in the scene when you change the blueprint. Please. Unreal. Please. Drives me absolutely fucking insane. What I'm more interested in really is the ability of this to basically allow me to fake proper interstellar movement even within a galaxy. Like,
Okay, so now let's try something else. So this is at 1,000,000. Let's do something realistically large, like 10,000, and then let's do actually like 1,000, and then let's make these larger, 100,000. So this should be stretching a Starfield. It's only 1,000. Oh wait, 1,000's too small with the size I have on the. Okay, file. Alright, so the distance between cubes here is only 1,000. So the idea here is that we will add logic to the player that as they travel, when they hit the edge of whatever we determine a stellar space, it'll probably be about 80 million. That will be equivalent to, like, it'll be like your position will be your position over 80 million, negative 80 million, right? And then that's going to be what's used to actually calculate the star positions. And we're going to give the ability to actually go really fucking fast and cover lots of space. To where you could cover that 80 million in, you know, a minute or two. Can I get to this? Things are moving. But this, keep in mind, this Starfield I'm looking at is only 1,000 units wide, and I've traveled way more than 1,000 units. And that's kind of the crux of the idea that I was trying to figure out. So I'm pretty happy with that. Okay, this is getting old. Let's go here. Let's change this to slightly less extreme. You can also kind of think of this idea in the same way as like the Rick and Morty episode where they're on the virtual reality treadmill and then the treadmill is just loading in the simulation on the ends of the treadmill as it's spinning. This seems to be working almost. And then if we really wanted to cut it, okay, so now we'll do 1 to 1, 1,000. So this is the speed you would navigate it. 1 to 1 speed. Seems to work. Seems to just work. So this will have to be a variable. This will be variable scene units to AU. We have to flip it. So theoretically, this should move the same speed as it was when the whole thing was sized to 1,000. Seems that way. It's moving crazy fast at us now. And these are quite big. It works, man. Just works. Alright. And now well, that won't work because I made them too big. Yep. All right. Well, I wasn't anticipating to hit my goal on this piece in one night, but and I still haven't. I have to do the material stuff, the dynamic material stuff. I don't know how to do that, and it doesn't look like many people do, because I couldn't find anything on it. This works. This is so cool. Scene unit's a universe unit. Distance scalar. And size scalar. Pile. Default will do There we go. This is going to be a kind of neat little toy to play with here. So now we don't get rid of our Starfield anymore and snap it on a cube map. Now we just leave it spawned and we'll repopulate it as the user moves around in space as needed. Okay, great. Expose all of these on the spawn. Universe coordinate. Expose on spawn.
with Teddy? Do you want to talk about dinner?
Alexa, broadcast.
What's the announcement?
Yeah, I'll be there in just a minute.
Announcing.
Yeah, I'll be there in just a minute. Alright, one more test. Then I'm gonna close it down for the moment. I'm gonna go get some pizza or something, I think. Now I just have a bunch of other math to figure out, but I'm going to take a break for now.